Hello everyone, and welcome back. In this section, as we move into week 11, we're going to continue using QM for Windows in Excel. This week we're going to focus on doing, or this week and next, probably we're going to focus on relatively simple problems. The kind of problems that we've looked at before. The reason being is largely because we need a solid fundamental knowledge of these computer programs before we move into increasingly difficult problems. So far, generally, we've had two decision variables. Actually, in every case, we've had two decision variables. In situations where we have two decision variables, we could solve manually. However, we are not solving manually because we want to work on the computer, because in the future problems will get more complex. As I said, we've had two decision variables and usually 2 to 5 constraints. In the future, we'll have 3 decision variables or more. Those problems are very difficult to solve manually, so we're going to become accustomed to using the computer. But before we can get to those complex problems, as I said, we need a strong base in solving basic problems, solving problems of the nature that we've solved before. These are the types of problems that we could solve manually, but we're going to solve with the computer. And most of them we've solved before. The reason being, it's not the actual problem solving that's important right here. It's becoming familiar with Excel and becoming familiar with QM for Windows that is critically important. So that's what we're going to focus on now. To begin today, we're going to look at one problem that was your homework from last time. So let's look at that now. You own a pizza restaurant, and you have just received an order for 100 pizzas for tomorrow. However, tomorrow is a holiday, so you are currently out of supplies. You also don't plan to open after preparing the big order, but you do need enough supplies to make that big order. To make 100 pizzas, you require 15 kilograms of pepperoni and 20 kilograms of cheese. You also have 2 ways of acquiring supplies. You can buy a large ingredient bag that contains 3 kilograms of pepperoni and 1 kilogram of cheese, or a small ingredient bag that contains 1 kilogram of pepperoni and 2 kilograms of cheese. The large bag is $5 and the small bag is $4. How do you meet your requirements and minimize your costs? So essentially, we see in the final sentence that we're trying to minimize our costs. So this is a minimization problem. We're going to minimize Z, which is costs. We have 2 choices, our 2 decision variables. We can buy small bags of ingredients or large bags of ingredients. So the large bag is X1, the small bag is X2. So now we have our objective function. Minimize Z equals 5x1 plus 4x2. You can see all of this critical information in the last sentence. The large bag is $5 and the small bag is $4. How do you meet your requirements and minimize your costs? Now we have to look at our 2, or maybe 2, or more constraints. The first one, to make 100 pizzas, you require, this is about halfway through the paragraph, to make 100 pizzas, you require 15 kilograms of pepperoni and 20 kilograms of cheese. Another word for constraints is requirements. We require those. So the first one is we require 15 kilograms of pepperoni. That's our first constraint. The second constraint, we require 20 kilograms of cheese. We have to get these 2 from our 2 possible sources, large bags and small bags. So the first one, we have x1 and the second is x2. So if we have we require 15 kilograms of pepperonis. A large bag is 3 kilograms, so 3x1 plus, and we have 1 kilogram of pepperoni in a small bag, 1x2 must be greater than or equal to 15, because that is the minimum we require. So our first constraint is 3x1 plus 1x2 is greater than or equal to 15. Our second constraint is the minimum 20 kilograms of cheese. So it's greater than or equal to 20 kilograms of cheese. We can buy a large ingredient is 1 kilogram of cheese. So 1x1 plus, and a small bag is 2 kilograms of cheese. 2x2 is greater than or equal to 20. So our second constraint is 1x1 plus 2x2 is greater than or equal to 20. This is our second constraint. We see now, very simply, that we have only 2 constraints in this problem. So we move to our problem formulation section, and we see that what I've said, I've compiled here. Minimize z equals 5x1 plus 4x2, subject to 3x1 plus x2, or 1x2 is okay, is greater than or equal to 15, which is the amount of pepperoni we require. And our second constraint, 1x1 or x1 plus 2x2 is greater than or equal to 20. And that is the minimum cheese that we require. So once we've reached this section, now we can go into our computer programs and solve once we format the problems correctly. Until now, we've gone first with Excel. Today, just to change things up, there's no reason, but just to change things up, we'll go into QM first. All right, once we come into QM, we always start with module. The reason is this is where we're selecting what type of program we're going to solve. We see quite a few different ones here. In our class, we've talked about break-even or cost volume analysis. Right now, we're on linear programming. In the future, not in this class, but in the continuation of this class, managerial decision making, we'll do several other ones like transportation or network problems as well. But for now, we're going to stick to linear programming. So we click here, linear programming, and we open a new window. A new program, not open. We click a new program. So we're going to title it, just for simplicity, clarity's sake, and that is the pizza problem. Our number of constraints, we can adjust up or down, but in this situation we have only 2, so we leave it at 2. Again, variables, we can choose as many as we'd like, but in this situation it's a relatively easy problem. We have only 2 variables. The key here is we have to click minimization. This problem is a minimization. If you make mistakes here, your entire model will not work. So in this first page, you have to be very careful. But we've done it. We have 2 constraints, 2 variables. It's a minimization. We click very simply OK. None of this is overly important. It can save us labeling, but it's not overly important. I mean, all of this we're going to rename in the next section anyways, so it doesn't matter. We're going to leave it as constraint 1, x1. Doesn't matter, because here, when we click OK, we're going to relabel to begin with. So X1 becomes large ingredient bag. X2, small ingredient bag. We're trying to minimize if our costs are $5 for a large bag and $4 for a small bag. And we see that in our objective function right here. Now, constraint number 1, our first requirement is minimum pepperoni required. Our second constraint is minimum cheese required. In both situations, we can start anywhere. It doesn't matter the order that we input the variables in. The keys are we need the correct values in each section, and we also need the correct sign. In this situation, it's a minimization, so the computer has automatically selected greater than or equal to. We can change that if we want, but in this situation, greater than or equal to is correct for both constraints. So we're going to leave it as is. We know we require 15 kilograms of pepperoni, and we know that we require 20 kilograms of cheese. We come in and we look at our constraints that we've found here. 3x1, x2, x1, 2x2. So we enter that information here. 3 and 1. Over here, 1 and 2. So essentially, what we've done is we've taken this information here, our problem formulation, and we've correctly inputted it into QM. That is, for QM, all we have to do. It's a relatively straightforward problem, especially at these easy levels. It's very easy to use QM. But remember, we're not totally focused on solving for problems at this point. What we're focused is becoming familiar with the programs. Correct answers are a bonus. Knowledge of how to use these programs is the focus. So right here, once we've entered all of this information, all we do is we hit solve. We see that now we have solved this problem. Our solution is we should buy 2 large ingredient bags, 9 small ingredient bags, and that will give us a cost of $46, which is the minimum amount we can spend at those price points to fulfill our minimum requirements of 15 kilograms of pepperoni and 20 kilograms of cheese. This is the minimum that we can spend. So we've solved it once, and again, because we're practicing, we're going to now go into Excel and we're going to solve this again. So here we go back to our problem formulation, and then we click on Excel, and we have a new spreadsheet here. So first thing I'm going to do, I'm going to label my spreadsheet as the pizza problem. Once we've inputted the pizza problem, our first step generally is to come down and to list our products. Or, in this situation, choices. The first one is, and we'll make all of this bigger, I guess, just for ease of reading. The first one is a large ingredient bag. The second, small ingredient bag. And in this situation, we're doing costs. So large ingredient bag is $5. Small ingredient bag is $4. We've seen that so far. This information, as I said, has been pulled from our objective function. Once we have our costs sorted, we come down here and we're going to input our constraints. So we'll title that requirements. The first one is minimum pepperoni. The second, minimum cheese. This is where we enter our constraints. So we have 3 in a large bag, 1 in a small bag, we have 1 in a large bag, and 2 in a small bag. Over here is usage, but we can't enter our formulas that we require yet. And over here we'll enter minimal requirements. If you remember, our minimum requirement for pepperoni is 15. Our minimum requirement for cheese is 20. And the number that we procure, the number that we get, has to be greater than or equal to these amounts. Greater than or equal to again. The usage, as we saw before, is going to be a formula. But we can't enter the formula yet because we haven't determined all of the relevant cells yet. So we're going to come down here, and this will be our choices. The first one is pepperoni. The first one is large ingredient bag. The second is small ingredient bag. And our final situation is cost. Now we know all of the relevant cells where all of the relevant information will be. So what we do here very simply is we have to enter our relevant formulas. Usage. To determine how much pepperoni we're going to get, we have to multiply the amount of pepperoni in a large bag times the number of large bags that we buy, plus the amount of pepperoni in a small bag times the number of small bags that we buy. This will give us the total amount of pepperoni we're going to get. And as we see here, this total amount must be greater than or equal to 15. Right now it will be 0 because we have no large or small ingredient bags yet, but as we change those numbers, this will fluctuate accordingly. One more time, we have the amount of cheese in a large bag times the number of large bags plus the amount of cheese in a small bag times the number of small bags. Again, it will be 0 for now, but this is how we enter the formula. Finally, we have one more formula to enter, which is our total cost. And to determine total cost, we multiply the number of large bags times the cost of a large bag plus the number of small bags times the cost of small bags. Once we've entered the number of small bags and large bags, which the computer will solve for us, this will multiply by our prices and give us our total costs. So we hit enter. It will be 0 now, but it will change as the computer runs permutations to determine our optimal solution. Right now, cost is 0. So we've entered all of our formulas. We have all of our relevant information. Now we click on Data, and we go over to the Solver function, which is on the far right-hand side. The first one we enter is where our ultimate goal is. In this situation, our ultimate goal is cost. So we click on B15. And we're trying to minimize. Changing variable cells, again, this is where we enter the cells that will change, that will fluctuate. This is where we enter the cells the computer will run permutations of. So we click here, B12 and B13, and we can drag the mouse down for simplicity's sake. Now the only step we have left is to add our constraints. So we go to the subject to the constraints and we click Add. The first one, our usage D7 must be greater than or equal to our minimum requirements F7. We add another one. For cheese, our usage D8 must be greater than or equal to our minimum requirements F8. And we click OK. We've added our two constraints. We have one more change to make. Simplex LP. And it will always be simplex LP. The reasoning is not necessary to go into right now. All you have to know is it will always be simplex LP. So we click solve on this problem. Solver found a solution. All constraints and optimality conditions are satisfied. We click OK. And we see here an identical solution. Large ingredient bags, 2 should be purchased. Small ingredient bags, 9 should be purchased for a cost of $46. That is the minimum amount we can spend to get 15 kilograms of pepperoni and 20 kilograms of cheese at these prices. We've solved the problem again successfully. Hopefully you have no questions. If you do have questions, do not hesitate to contact me. Hopefully I can help you with those. Let's move on now to our second problem. This is practice question number 1, the Crumb and Custard Bakery. It's chapter 2, question 7 on page 82-83 of your textbook. The Crumb and Custard Bakery makes coffee cakes and pastries in large pans. The main ingredients are flour and sugar. There are 25 pounds of flour and 16 pounds of sugar available, and the demand for coffee cakes is limited to 5 cakes. 5 pounds of flour and 2 pounds of sugar are required to make a pan of coffee cakes. 5 pounds of flour and 4 pounds of sugar are required to make a Danish. Coffee cakes have a profit of $1 and Danish has a profit of $5. How can the bakery maximize daily profit? Generate and solve a linear programming problem to determine how much to manufacture of each. Very simply, we're going to read and interpret this and ultimately get this situation. We're trying to maximize z equals 1x1 plus 5x2, subject to 3 constraints. The first constraint is the minimum amount of flour, or the maximum amount of flour that we have. The second constraint is based on the maximum amount of sugar that we have. And the third constraint is limited to demand for coffee cakes. It's limited to 5. So in this situation, we have 3 variables. Again, once we have this information written in this format, it is relatively easy to solve. So we're going to leave our PPT, and again, we're going to go into QM. I'm going to save these problems very quickly. And we can open a new module. So we come down here to linear programming. We're going to open a new file. And it is now our crumb and custard problem. We have 2 constraints as we saw, but we have 3 variables in this situation. And we're trying to maximize. So we click OK. Our first, oh, my mistake. Number of constraints is 3. Number of variables is 2. That was my mistake and something that we have to be aware of. So crumb and custard problem. We have 3 constraints and 2 variables. Constraints is listed first, variables second. We're trying to maximize. We click OK. And our first variable is coffee cakes. Our second variable, Danish. We know from our problem that we get $1 for a coffee cake, $5 for a Danish. We're trying to maximize our profit given these prices. The first constraint is, the first limitation or constraint is max flour available. And we know from the problem that we have 25 kilograms available. So our total, our usage has to be less than or equal to 25. Our second constraint is max sugar available. And here again, we know we have 16 kilograms of sugar, so it has to be less than or equal to, has to be less than or equal to 16 kilograms of sugar. And our third constraint is max coffee cake demand. So we're going to come here, max flour available. We know it's 5 kilograms of flour for a coffee cake and 5 for a Danish. And that has to be less than or equal to 25 total. Max sugar, we know it's 2 kilograms and 4 kilograms. And that has to be less than or equal to 16. Finally, coffee cake has to be less than or equal to 5. So the way we say this is coffee cake is x1, so we make this one 1. The total number of coffee cakes multiplied here has to be less than or equal to 5 in total. This is how we enter this information. Here is our key information here, and we entered in QM like this. Once we've done that, very simply again, we click Solve, and we see that we manufacture 0 coffee cakes. Any coffee cake we manufacture would hurt our ultimate revenue. Instead, we want to use all of our resources to manufacture only Danishes. And this makes sense if we look here, because we make 5 times as much money from a Danish. It seems right away that to manufacture coffee cakes would be foolish, because Danishes are 5 times more profitable. And the ultimate solution has shown us this is correct. We should manufacture 4 Danishes, which would give us a total profit of $20. With the resources we have, this is our most profitable situation. So one more time, we'll save this. And then we'll go over to Excel. Now we'll save this one too. and then we'll open a new file. And we'll label it as the crumb and custard problem. First thing, we'll expand our columns. We'll come down here and we'll mention our two choices, or in this situation, products. The first product we manufacture is coffee cakes. The second, danishes. And we know that we make $1 for a coffee cake and $5 for a Danish. So this is our revenue. Now we have to come down here, and this is where we enter our constraints as before. So we'll type heading as resource. The first one will be we have a minimum or maximum flour available, max sugar available, and demand for coffee. So now we have our resources, and in this situation, coffee cakes takes 5 units of flour, danishes 5 units of flour, and our total usage we'll put over here. Coffee cakes take 2 units of sugar, danishes take 4 units of sugar, and our usage again. Finally, demand for coffee we know is 1, and our usage will be over here. We're going to add our signs in here, so it's less than or equal to for each of them. Less than or equal to, less than or equal to. And this is our total available over here. All of this should be relatively straightforward now because we've done it quite a few times. And our total available is 25, 16, and 5 is the maximum demand. So now all we have to do is enter our usage formulas. But before that, we have to come down here and we enter our products. The first one is coffee cakes. The second, danishes. And our ultimate goal is revenue generation, and we'll enter that here. So we come up here to usage and we have to enter our formula. So the flour we use is equal to the flour per coffee cake times the number of coffee cakes plus the flour per Danish times the number of danishes. Right now, 0. But as it changes, this will increase. We repeat that again. The number of sugar is the amount of sugar per coffee cake times the number of coffee cakes plus the amount of sugar per Danish times the number of danishes. And our ultimate demand is very simply is equal to 1 times the number of coffee cakes we make. We're multiplying this times this, and this number that our total number of coffee cakes must be less than or equal to 5. Finally, revenue is equal to our total number of coffee cakes times our money per coffee cake plus our total number of danishes times the number of danishes. And we hit enter to get 0 for now. We click up here on data and over to our solver function where we enter the relevant information. So our goal is to maximize revenue, which we find in B16, It's a maximization. We're changing cells B13 and B14. We add our constraint number 1, which is D7 must be less than or equal to F7. Our usage of sugar, D8, must be less than or equal to our available sugar, F8. And our number of coffee cakes, D9, must be less than or equal to 5, or F9. We hit OK. We change this to simplex LP, and we solve. Solver found a solution. All constraints and optimality conditions are satisfied. We click OK. Oh, and it's changed back. 1 second, everybody. It changed back to my pizza problem. So we come over here and we change it back to book 2. And we see the identical solution. We manufacture 4 danishes, which will give us a revenue of $20. That is our ultimate optimal solution. So the last thing I'd like you to do today is, after having watched all this, I have another problem for you. I'm going to put it up on the sheet now, up on our PPT at the moment, and I'd like you to solve this problem using QM and using Microsoft Excel. When you have finished that, please answer your attendance quiz for this section. I'll leave this on the sheet or on the screen until the 45-minute mark, and then I'll address you one more time. All right, hopefully everybody was able to find the proper problem formulation. Once you find the problem formulation, this problem should be relatively straightforward. It will be important for you to find the problem formulation to solve properly to answer your daily attendance quiz. So I hope that worked well for you. As always, if you have any problems, please let me know. And if you do not, thank you everyone for listening. We'll continue in the next section.